So good morning to all present over here. So today topic what we are going to see about now, we are going to see about an smart sensor. So smart sensor is to be an analog or digital transducer which combined with the processing unit and the communication interface. It consists of transduction element, signal conditioning, electronic and controller processor which supports some intelligence in a single package. So this integrated sensors which has electronics and the transduction element together on one silicon chip. These systems can be called a system on chip. So the main aim of integrating this electronics and sensor is to make an intelligent sensor. It is used to, the thing is to be that we'll be having on it. So in order to make some decisions, okay. So when you are saying about an smart sensors, so it are intelligent sensors which is integrated with electronics that can perform one or more of the following functions. That is, it can able to have a data conversion, or we may have one bidirectional communications. Similarly, it can able to take decisions, or it will perform a logical operations. So when you are saying about over on it, so this is the thing. There is the sensors will sense the process, and it will collect and it will displace and it will make some decisions making. So thing is to be that we'll be taking off and processing over also around it. Okay. The next thing, definition. So definitions, it can with this integrated electronics, it can able to perform the logical functions, or it can able to have often two-way communications, and similarly it can able to make a decisions over on it. Okay. The next thing, when you are saying about a usefulness, the thing is that it is made with some technology as an integrated circuit. So it is have a transduction element, either includes thin metal films, zinc oxide, or some polymeric films. It utilizes the transducers and then properties of materials and electronic properties of silicon. So integrating electronics on the sensor chips makes it possible to have a single chip solution, whereas integrated sensors provide significant advantages in overall size and the ability to use small signals from the transduction element. What about the architecture? So it have a following components. One to be the sensing element, another to be the amplifier, third one to be the sample and hold, fourth one to be the analog multiplexer, fifth one to be the ADZ, sixth one to be the offset and temperature compensation, digital to analog converter, and then finally we'll be having about an memory and 8-bit serial communication process. So this is the block diagram which consists of the elements sample and hold, analog multiplexers, processors, serial communications, offset corrections, drift compensations, transducers, analog multiplexers, ADZ. Then memory will have a DAC module. Okay, so descriptions. So the thing is to be that in the architecture we'll have about 10 the amplifiers and the sample and hold circuits corresponding to different sensing elements. In order to get a digital from an analog signal, the analog signal is periodically sampled, and that constant value will be held and converted digital words. Any type of ADZ must contain or preceded by a circuit that holds the voltage at the input of the ADZ converter constant during the entire conversion time. So ADZ starts conversion when it is starts of conversion signal from the processor, and after conversion is over, it gets end of conversion signal to the processor. So the outputs of sample and hold circuits which are multiplexed together and then use a single ADZ, which will reduce the cost of the chip. So offset compensation and correction comprises of an ADZ, which measures the reference voltage and other for the zero, dedicating 2 channels of the multiplexer and using only one ADZ for whole systems, which can avoid the addition of ADZ. This is helpful in offset corrections and zero compensations due to temperature drifts. In addition to this, it includes internal memory so that we can store the data programming. What about the importance? It reduces the cost of bulk cables, it remote diagnostic and cost-wise improvement. So it also have on it. So importance, it will have a system reliability. So it is improved due to the digital smart sensor. So it will have a better SNR ratio. So since the output is very weak and it is transmitted through long wires, so lots of noise gets coupled by using smart sensor. And applications, it can able to have a self-calibration. It can able to have a computations, communications, and will have a multi-sensing. What about the functions of electronics? So many times it is required that an example of this is silicon wheatstone bridge where the drive voltage is increased with increasing temperatures. Similarly, it is used as an analog input and will have a data conversions also. Okay, and the next thing is to be that we'll have a digital bus data bus interface. Thing is to be that it is wiring is reduced considerably, automatic calibrations and productions. So we'll have a monitoring and diagnostic functions, and then we'll have a control processes. The characteristics, important characteristics are to be the non-linearity, cross sensitivity, offset, parameter drift, and component values. The next thing we have to see about film sensors. So thin film sensors, which is produced by directly depositing materials in a vacuum deposition chamber, which is known as sputtering. The sputtering systems which allows process control so that the films may be produced with a high degree of repeatability. Whereas in the case of thin film circuits, it is formed by the deposition of layers of the special paste onto an insulating substrate. The parts of thick film circuits, it can be made sensitive to strain or temperatures. Similarly, what is laser sensors? The laser sensors, which is detecting pressures and others measuring distance. So this distance sensors, which are focused, use a coherent light in order to measure distance to a targeted object. So in factory automation applications, the target is automatically a product or a machine element. So they can detect any solid objects or produce an output proportional to the measured distance, which is independence of materials, colors, and brightness. Where the high resolution output, which is provided by the laser distance, is to provide position or displacement, usually to the input of some type of industrial controller. So we'll have several types of laser distance sensors, which include diffuse, background suppressions, and retroreflectives. So these sensors use CMOS or transfer time technology. And similarly, the laser light must be